Hello everybody, this is the continuation of the previous theoretical class on array. This is a practical session which I will be going through on array and two-dimensional array. Now I have prepared a presentation just to recap the theoretical concepts. Now array is a derived data type, as I already explained in my last lecture. And what is a derived data type? Why is array called a derived data type? Because array is a derived data type because it cannot be defined on its own. It is a collection of basic data types usually, such as integers, doubles, floats, booleans, etc. So it cannot be defined on its own. All arrays must be of certain type, of certain primary data types, such as integers, doubles, floats and booleans. So that is why they are not primary data type but derived data type. Now just to recap the memory allocations of an array, if I declare an array as int a7, fine. If I declare it as int a7, then the array will be stored in the memory as a0, a1, a2, a3, a4, a5 and a6, and each of the values will be taking 4 bytes, assuming that we are using a 64-bit architecture. And there should be an iteration variable called I, which is declared, which here, as you can see, it should be comma. Okay, and the size of the array is 7, and the name of the array is A. So what is the purpose of I? I needs to traverse between 0 and 6, okay, so that we can get through all the elements of the array, either if we want to input them into the memory or we want to print them onto the terminal screen. So this is how the memory is allocated within an array, in a one-dimensional array or simple an array. Now how is memory allocated in a 2D array? As you know, I already explained you that suppose this is the 0th row, okay, this is the first row and this is the second row. So this one is 1, this one is 2, okay, this one is 2, and this one is the third row. And similarly we are getting 3 columns here. This is the first column, this is the second column, and this is the third column. Okay, first column I will represent it as 0th column, because array element starts at a0. So naturally the second column is being indexed as first, okay, and the third column will be indexed as 2. Okay, this will be the second of the array index. So I am not repeating it for the columns. It will be the 0th column, this will be the 0th column, this will be the first column, and this will be the second column. So naturally if you match this, then the location of this element, is 0, 0. This is 0, 0, because we have matched this row and this column, fine. Similarly it will be, say, like 0, 1, it should be 0, 1, okay, it should be 0, 1 for this particular row is 0 and this particular column is 1, and then it will be 0, 2, then it will be 1, 0, 1, 1 and 1, 2 depending on the row and the column number. And see the memory allocation, first the first row corresponding to 0th row, okay, all the elements like the element 0, 0, 0, 1 and 0, 2 will be stored in the memory. Then correspondingly the second row and the third row by matching with the matrix, okay, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, that will be stored in the memory in linear fashion. So that is all about the memory allocation. Now it will be very simple if we move into the Cygwin terminal. Okay, if we move into the Cygwin terminal, so our program is open in front of us. This is a program to demonstrate array and to print the elements of an array and sum the elements of that array. Okay, so what will be the input? Input will be an array, okay, and the output should be the sum of the elements of those array. To clarify, suppose our array is of size 10, so user is capable of entering any 10 numbers, any 10 integers better. So those integers will be the input and the output should be the sum of those integers. Now how to do this using an array? Definitely we need to we need to declare one particular array, okay, as I have declared here as int a10. That means the name of the array is a and its size is 10. We need one iteration variable I, as I explained you a minute before, that I must be declared so that it can traverse to the elements of the array, that is between 0 and 9 in this particular case, and we are taking a variable called sum and initialize it to 0, which can hold the sum of the elements of the array. So in the first step we are declaring this. In the second step we are asking the user to enter the 10 numbers. Then we are executing the for loop. See that for I equal to 0, I less than equal to 9, I plus plus scan it %d ampersand ai. That means for I equal to 0, a0 is being populated. For I equal to 1, a1 is being populated, and likewise for a9 the 10th element is being populated. Okay, so here is the punch. Within the for loop we have written one particular assignment of like sum equal to sum plus ai. You know from the program that I have declared sum as 0. Okay, so it is initialized to 0, and what happens for I equal to 0, sum is equal to sum plus a0. Now a0 will be holding a particular number, whichever the user enters first, that will be stored in a0. So that particular value, say user entered 1, so the new value of sum after first iteration, after first pass, should be 0 plus 1. So the new value of sum is 1. And suppose at a1, that is the input being next given by the user, is say 3. So for I equal to 1, the value of a1, that is 3, must be added to the existing sum, that is 1. So the new sum should be 1 plus 3, that is 4. So in this way, as and when the elements are entered and being scanned in the memory, they are simultaneously added with the previous value of sum. And after the loop is being executed, that is after reaching the terminal condition at I equal to 9, the last value, that is a9, must be added to the all the sums which have been taken till a8, and finally the sum will be holding the addition of all the elements of array A. So finally, after ending the for loop, I am just printing that the sum of the array of numbers is %d and our name of the variable is sum, so comma sum. Now let's see that how is the program running. Let's exit the screen. Let's compile gcc sum array dot c minus o sum array. So our program has compiled. Now I will simply run this program. So as per the program, I have to enter 10 numbers. Let me enter 10 arbitrary numbers here. So I have entered 10 arbitrary numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think it's what's 11. So it is 10 numbers. We can't add the 11th number because our array was predefined as int A10. So the size of the array was 10. So maximum we can put 10 numbers here. So the sum of the array of numbers is 222. That means we have got the sum of the elements of the array successfully. So that is how array works. There are numerous examples which can be given, which maybe I will be taking up in subsequent times, and we will be using arrays frequently during the part of the course. So array shouldn't be a problem if you have the preliminary idea, and if you know how to read the elements of the array, how to print them, okay, how to execute the for loops and all. So it shouldn't be a big problem, and we will be using arrays extensively in our subsequent classes. So I don't think that at this point of time we need some more explanation on this simple array. So let's see that how a two-dimensional array works. Now I have already written a program, as you can see on the screen, 2D array.c. Let's open that. 2D you can easily understand that how this is working. This is a simple program and I have commented each part. So suppose I am inputting a matrix, okay, 2 cross 3 matrix I have to input. So I have declared the array as disp2 3. That means it will be having 2 rows and 3 columns, and instruction is that I have to enter a 2 cross 3 matrix, and you know in a 2 cross 3 matrix the number of rows is 2 and the number of columns is 3. Now we are using counter variable. See, some also writes counter variable, iteration variable, then intermediate variables. These all are interchangeable terms, okay. As per the work they are doing, we can name them. So those two are I and j. I will be iterating through the number of rows and j should iterate through the number of columns. Now I have to run a nested for. Why nested for? Because as you have seen in the presentation, let me open it for you again, that to access the 0 0 location, I must be 0 and j should also be 0. Then to access the 0 1 location, I should be 0 and j should be 1. Then to access the 0 2 location, I should be 0 and j should be 2. And how these for loops work: for each value of I, okay, j should run. For each value of I, j should run. That means for I equal to 0, we have to execute all values of j. Then for I equal to 1, we have to run all the values of j. Again for I equal to 1, okay, because there are 2 rows, so it should be less than 2. So for 0 and 1, I must go through 2 values only as per this problem, okay, because the number of rows is 2. So for 0, all the j will be running once, and for I equal to 1, all the j's will be running again. As such, we will be getting 0 0, 0 1 and 0 2, and again we will be getting 1 0. We should be getting 1 0, 1 1 and 1 2. Fine, for the second row. So that is why again another point to note here is that the number of column is 3, so j must be less than 3. J must be less than 3, because as you can see from this diagram, that j is 0th column, first column and second column. That is why it is 3 columns, okay, that is why it is 3 columns. So the value must be less than 3, as the value starts at 0th column. So it is absolutely fine. I think for each value of I, J must execute. So for I equal to 0, J will be executing. The whole loop having J should be executing, and for I equal to 1, the whole loop having J must be executed again. So naturally we will be reading all the values like 0, 0, 0, 1, 0, 2, then 1, 0, 1, 1 and 1, 2. Finally we will be displaying the array. We will be displaying the array. Okay, like printf, the 2 cross 3 matrix is again same. We will be running a nested for loop to print each element of I and j. Okay, and we are displaying it. Now see, there is an if condition at last, that if j equal to 2, we need to print the resultant matrix. Why if j equal to 2? Because j equal to 2 means that we have reached the last entry. We have entered the value of 1, 2, and when we enter 1, 2, our 2 cross 3 matrix have been already entered. So that is the condition when we will print the matrix, and that is why to print each row and columns, set of each row and column once on a single line, we have given a printf /n. Otherwise the rows and columns or the elements in each row and column will be marked up. So we have given a printf \n. Now let's run this program. Now we should first compile it. GCC 2d array .c -o 2d array. Oh, that is fine. That is okay. So we have successfully compiled this. Now just run, enter a 2 cross 3 matrix as per instruction. So enter value for the matrix, that is 0, 0 position we will be entering. So we have entered one value. Now enter the value for this 0, 1. That means we need to add the second element of the first row. So we will be entering 3. Likewise we will be entering all the elements, and see the 2 cross 3 matrix is 1, 3, 6, 7, 6, 7. That means 1 will be 0, 0 position, 3 will be 0, 1 position, 6 will be 0, 2 position, 7 will be 1, 0 position, 6 should be 1, 1, and 7 should be in 1, 2. This is how we input a 2-dimensional array in memory and print it. Okay, and matrix is the best example to demonstrate that. Now if you want to take a note of the program, so I will open it for a few seconds so that you can take a note. Okay, remember, it is always a good practice to declare main as int, okay, in this kind of environments, and you have to write a return statement. We will be knowing this in detail when we learn functions. So since main is returning int here and nothing is returned, but its return type is integer, so to mark the end of the program we have returned 0, and rest of the things are self-explanatory, as you can see. So now they will see an application of the 2-dimensional array, that is matrix addition. We will be looking into it. Let's clear the screen, make an ALS to see whether the program exists, and you can see that there is a program called matrix sum. So let me open it in the nano editor, matrix sum.c. So it looks large, but it is not that hard at all. Now see, you know what is a matrix. Matrix means that it is a structure, okay, which is having a particular number of rows and columns, and while adding a matrix, we know the corresponding elements of the two matrices are added together. Now in a matrix A, I have declared one matrix as matrix A and its size is 3 3. Why 3 3? Because our program is to add two 3 cross 3 matrix. So when we add two 3 cross 3 matrix together, the resultant matrix must also be a 3 cross 3 matrix, no doubt about it. So the first two matrix will be given as input by the user and the third matrix will hold the sum of the matrix A and matrix B. Okay, the sum of the matrices will be held in matrix C, and matrix C should naturally be of 3 cross 3 in dimension, because the corresponding values of matrix A are just added to the values of matrix B, and the resultant should be 3 cross 3. So that is why we have declared three matrices. Now we have declared three, whatever you can say, iteration variable, intermediate variable, control variables, okay, like R, C and K. Now R represents row, C represents column, and K will be used later just to print the third matrix, that is mat C 3 3. That is the third matrix, the resultant matrix, which will be holding the sum of the matrices A and B, which you will enter, and through display it I am taking K as the control variable so that it can be printed. Now since it is a 3 cross 3 matrix, so the number of rows must start with 0 and it must be less than 3, and like the earlier program, to input the columns we will be starting it at 0 and we will be ending it at 2, and that is why it should be also less than 3, and we should increment the column each time. That means for each row the corresponding values of columns must be read, and that means we will be reading 0 0 0 1 and 0 2, then we will be reading 1 0 1 1 and 1 2, and finally we will be reading 2 0 2 1 and 2 2. So this will be a 3 cross 3 matrix, and this is similar to the one which I showed you, because this is the 3 cross 3 matrix, so it will be running in the same way. As you can see that here are 3 columns and 3 rows, and since the number of rows and columns starts at 0 0, so they must be less than 3. So this is how we actually input matrices A and matrices B. This portion is inputting matrix A, this portion, the highlighted one, okay, and this portion is inputting matrix B in the memory. Now these two are very easy as the one I showed you, how to read the inputs of a two-dimensional array. Now see the third part, that is from where the resultant sum is being calculated. So I am moving to that portion. I am marking it first for R equal to 0, R less than 3, R plus plus, for C equal to 0, C less than 3, C plus plus. Now for now remember that matrix A and matrix B have already been inputted, but still to determine matrix C we have to read them, otherwise the third matrix cannot be calculated. So we have to run these loops again for row and column, and we are setting our resultant matrix row and column to 0, that is we are resultant matrix, the sum matrix, okay, whichever will be holding the sum is assigned to 0, that is why mat C RC is equal to 0, okay. Now the third matrix, as I told you, must be of the same dimension of the matrices of which we are making addition. So naturally the third control variable, which is determining the rows and columns of the third matrix, okay, that should also start with 0 and will end with less than 3, that is 2. So for k equal to 0, k less than 3, k plus plus, okay, I have to do it how many times? I have to do it 3 times, is not it? I have to do it for 0th column, for first and for the second, Okay, so it is starting at k equal to 0 and it is ending with k equal to 2. So what will be the value of matrix C then? Matrix CRC should be just simply the sum of the matrix A and matrix B, and the corresponding elements must be added. The corresponding elements of matrix A and B must be added and stored in that particular index of matrix C. In other words, I mean to say that the value stored in 00 address of matrix A and the value stored in 00 address of matrix B must be added together and stored in the 00 element, okay, of matrix C. Similarly, it will happen for 01 and 02 and 20 and 21 and all of the stuffs, as you can see. For each will happen for all the addresses, all the locations for 00, 01, 02, 10, 11, 12 and so on, and they should be added together and stored in the corresponding elements of matrix C. Now the addition matrix we can just print. Again, we have to iterate through the rows and columns of the third matrix, and we need to print the third matrix. So naturally we have to type here %d matrix CRC and just mark the new line so that rows and columns of the third matrix doesn't mix up. And finally, because of the int statement, because we declared the return type of main as int, we have put a statement called return 0 to mark that the program has successfully terminated. So this is all. I don't think it is much tough. Still, you have any questions on this particular program, okay, you can always write in the comment section. Similarly, it can be shown that a matrix multiplication can be performed in a similar fashion, just depending on the logic, where we know that the number of columns in matrix A must be equal to the number of rows of the matrix B. So that check we need to put and do the corresponding multiplication, okay. So that I haven't shown here. On request, I can also put up that program for your reference. Now if you understand the logic, I don't think that will also be a big problem. Anyways, let's check whether this particular thing is working or not. So let's check it. Just compile this matrix sum.c gcc matrix sum.c minus o matrix sum. We have successfully compiled the program. Now we will just run this. So now we will be entering the first matrix element 0 0. Now let's enter. You can check it by yourself what happens after execution of this program. I am just typing random numbers as the elements of the matrices. So now you can easily verify that the addition matrix is this one. How we have done it? For the first matrix, the corresponding elements are added together. That means element 0 0 of first matrix is added to element 0 0 of second matrix and stored in the element 0 0 of the third matrix, that is the addition matrix. So you can check that 6 and 90 are added together, 7 and 98 are added together, 9 and minus 9 are added together, again 8 and minus 12 are added together, 0 and 67 are added together, so on and so forth. So we are successful in adding two matrices, and I think you have understood that how we implement an array, okay, how we implement a simple array, how we input the elements of an array, print them, and we can do operations on them, and also I have tried to explain you what a two-dimensional array is, how array and two-dimensional array are stored in memory, what are the locations at which they are stored. Then I also taught you about the minimal operations and the practical use of two-dimensional array and array. And as I told you that array we will be requiring extensively during this course, so there is no point in spending more time on how array works. This is just a preliminary idea, and as we progress in the course we will be using arrays frequently, and gradually through practice you can grasp these concepts, and you can also solve many problems given in your class or given in your college. Okay, and if you are a programming enthusiast, then you can also find many problems on the internet. And I hope this lecture on array and the practical session on array is useful to you. Okay, and as I repeatedly tell you that programming is practice. It is not that I am showing you 2-3 programs and that is it. No, we are all learning in this programming, we have to practice a lot. Okay, I am also learning with you. Okay, so there is no end to it, and keep your heads high, practice hard, and you will definitely succeed. Anyways, thanks for watching this patiently. It was been nice talking to you. Keep following us and keep supporting us in the days to come. Thanks a lot. See you soon. Bye.